This lesson is just a short introduction to our next topic, which is vectors. For vectors, we'll do a short unit on it. It really helps us for the rest of this semester. And we'll learn a few things about it. You'll learn it also in math this year if you haven't already. And today's lesson is, like I said, just a short introduction to that. We'll talk more about how they work a little bit later in class. So let me tell you about vectors. Vectors are really just a physics way of solving problems, and it's a little bit easier using vectors because you take physical quantities like 30 miles per hour or 15 meters per second north and you turn it into a picture. It helps you solve problems in all sorts of ways, which you'll see coming up in the next week or so. So, first of all, you need to know that a vector is a picture that represents a quantity. And let me remind you at this point that you should have a notebook out taking notes on this stuff. That's how these flipped lessons work. And of course, when you're finished, you're going to be filling out a Google form to show me the things that you've learned. So here we go. A vector is a picture that represents a quantity. I kind of said that before already. Here's an example. This is a vector that shows a 4-meter displacement at 47 degrees north of east. There it is. Vectors all have direction and magnitude. You can see that in this picture. I've got this line here that shows the magnitude, that's the amount. In this case, the magnitude is 4 meters, and the direction is 47 degrees north of east. So this would be like the east line. If you think of north, east, south, and west, this is the east line, and we're going 47 degrees north of that. So this direction is 47 degrees north of east, 47 degrees north of the east line. The way we usually draw vectors is that if they have a large magnitude, we draw them as a larger vector. Let me give you an example. Here I have two vectors. They are different directions, of course. One is north of east, like the one up above, and one is due east or straight east. This is 2 meters straight east. Well, because this is a shorter or a smaller magnitude, I draw it as a shorter vector. And ideally we draw them to scale, so that ideally this one would be 2 or half the size of this one. Now it doesn't have to be that way, but we try to make the smaller magnitudes a smaller vector and the larger magnitudes a larger vector. Again, it helps us keep things straight as we solve problems. When I take two vectors and I add them together, I get one resultant vector. And that's what this is. This right here is two vectors added together. You notice I added them tip to tail, and that's really important. I'll say that a lot in the next week. We add vectors tip to tail. So I did the tip of one on the tail of the other. And when you add them together, you get one resultant. That green line represents the resultant. That is, that this one vector is equivalent to these two vectors added up. And again, you'll see that more in the next week. A scalar is something different. So a vector has a direction and a magnitude. A scalar has a magnitude but no direction. You might be able to think of some things that are scalars. We've talked about some in class already. Some things that have a magnitude, a value, an amount to them, but they have no direction associated with them. Things in physics, as in all of science, are either scalars or vectors. Some things you measure cannot have a magnitude. They cannot have a direction, but they all have a magnitude. That leads me to some of your home learning tonight, and this is going to be on the Google form. On the Google form, I'm going to ask you to list 4 vector quantities from things you've already learned and 4 scalar quantities. So think about things that have a direction and a magnitude. That's vector stuff. And then think about things that are scalars. They have a magnitude, but they have no direction. Don't forget to fill out the Google form, and if you need to go back and listen to these notes and write some more things down again, you can do that anytime.